Great. So yeah, first of all, welcome everyone for the fourth event of Cloud Native Computing Links. Um, I'm Giuliano. I'll start with a couple of slides and then I'll pass to the presenters so we can have this call. Jürgen already mentioned, but this is the first time that we choose Zoom to do it. And we want to have some interaction in between the talks. So hopefully everyone will enjoy, and any feedback that you guys have for us is awesome. So here we have our Twitter and where you can follow the community. So most probably you guys are already there, but if you're gonna take a screenshot or comment something, please tag us and help us promoting the group. So here we have the agenda. I'm starting now with the welcome message. The first speaker will be Oded from Rookout. Then at 5:50, we'll have some networking with an ice-breaking event and interaction. Jimmy will take at 6:10. Jimmy is from Wizas. And at 6:50, we do some closing remarks and we will do the raffle. So we have a couple of gifts that we got from CNCF and also from Rookout that we would like to give for the raffle to the community. So we will have some type of raffle in the middle of the call, and then I'll get the address and post then those gifts for you. Cool. So the community, we follow a Berlin Code of Conduct. If you would like to know more about the whole Code of Conduct, please visit berlincodeofconduct.org. But the main point is be kind and respectful. So everyone is in the same call here. We can unmute ourselves to talk. So please, whenever you do, be respectful and think that someone else is speaking. So everyone is doing this voluntarily. So it is nice to have some appreciation on that. Yeah, so also another thing that the Code of Conduct mentions is that everyone is welcome. Doesn't matter your level, your gender, or your nationality, whatever. Everyone is welcome in the community. The community is ran by me and by Jürgen. Well, I'm a software engineer at Dynatrace. That's my Twitter handle if you want to follow me. Usually I just post things related to the meetup and Twitter. I'm not that much active. Jürgen, would you like to say something about yourself?
Yeah. Hi, everyone. My name is Jürgen. I work just by chance at the same company as Giuliano, and I'm one of the co-organizer of this meetup. Thanks for joining. You can also find me on Twitter. I mostly tweet about open source and cloud native technologies. I'm also a maintainer of an open source project called Captain, which is a CNCF project. And yeah, thanks everyone for joining, and have a great meetup today.
Thanks. So we would like to thank Rookout, our sponsor for today. Rookout helps you troubleshoot issues on Kubernetes. Most probably that's what Oded will cover in his presentation today. So I'll leave to him. But also I would like to thank them because we will send the gifts for you to whoever win the raffle. So for this, we need to pay the post and everything, and they are helping us with that. So we really appreciate that. If you have something, if you are working with something related to cloud native computing and you would like to talk about it, we are looking for speakers. You can register your talk at tinyurl.com/CNCLinz-talk. And if you're a company or if you know a company that would be interested in supporting the community, the same tinyurl.com/CNCLinz sponsor. We have a form over there. You can fill up the data and we'll get in touch with you. We will post these links on the chat afterwards, but we have some community news here. And if you are looking for some free workshops related on the cloud native technology, we have this first one that is powered by Microsoft Austria. They helped us in our first event, and they have some free workshops that are running now at the beginning of February. It's nice if you're interested in and looking for something to study. And we would like also to invite everyone to take a look into the Linux Foundation mentorship program. Jürgen, would you like to talk a little bit about this?
Yes, so just briefly, it's a paid mentorship program provided by the Linux Foundation. It was previously called Community Bridge, and students or whoever wants to sign up for this program and is eligible for this program can join a CNCF project, an open source project, and work with the open source maintainers for a period of roughly 3 months. So if you want to apply for this, I would say it's perfectly suited for students, but I think there is no age limitation or something like this. And you will find all the information on this URL. Again, it's a paid mentorship program if you want to start your journey in open source and in cloud native projects. I think it's a great start to do so. And just by chance, we also, with the Captain project, we're also participating there, but you can choose whatever project you want. There are great projects out there, starting from Kubernetes to Prometheus to a lot of other great things. So just if you're interested in.
Awesome, thanks. And well, most probably you already know, we are on Discord. If you want to keep this conversation afterwards, just join us at CNC-Discord, at the same tiny URL, and you'll get access to our channel. So today's speakers, we have Oded Keret, that is a director of product management at Rookout, and we will start with him. And after our breakout sessions in the middle of the event, we come back to Dimi, that works with us as a senior consultant. So thanks again for the speakers. And Oded, the stage is all yours.
Thank you, and thank you everyone for having me. It really feels like visiting abroad. It's a very good feeling, and I missed it. The picture of the view in Linz looks very promising. So thank you for the introduction. My name is Oded. I'm a product manager at Rookout. In previous roles, I used to work in performance testing and monitoring tools. And in the past couple of years, I've joined Rookout, which is a startup that is looking to help developers debug in places where debugging used to be hard or even impossible. When I joined Rookout, the mission statement was debug in production. Do something that seems impossible, seems dangerous, but nevertheless seems necessary sometimes. And as we started approaching customers and learning about what they use Rookout for, we actually learned that almost 80% of our customers actually use Rookout for debugging in staging and integration environments, which surprised us initially. But we quickly learned that the reason they do that is because their applications are cloud native, usually Kubernetes based. And when you are developing and deploying a Kubernetes application, sometimes debugging in staging or even debugging a single local microservice is as hard or as far away or as time consuming as debugging in production. So having a tool like Rookout really helped them improve their efficiency and the quality of their products. And today I would like to share with you some lessons that we have learned from our customers as we developed the product into what we hope to proudly call a cloud-native debugging solution. So let me start, because you always want to start a presentation like that with some statistics or some pie chart. We asked over 100 development managers and DevOps teams managers, how long on average does it take them to handle a support case or a customer issue, an incident? And most of those develop cloud native applications. Most of those are in Kubernetes. Almost all of them have a very advanced CI/CD pipeline and a very advanced observability platform that basically they have all the logs they need, they have all the alerts they need. They are able to push a change in a hotfix quite quickly. For some of them, lead time is minutes or hours. And still, with all of that velocity and all of that observability, it still takes them almost half of them over 2 days to solve a customer issue. And we know how painful it is. As engineers, we know that it hurts the business when a customer is unhappy, when there is a piece of POC on the line, or when there is an application that's not meeting its uptime SLA. And we also know the frustration on the R&D side, on the engineering side, with business on your backs, and with the frustration of no matter how long it took you, it feels like it took you too long. So we wanted to understand what we can do to solve that. And the first thing we did to try and solve it is try to understand what is the most time-consuming or frustrating part of solving a customer issue. And I'm going to ask it rhetorically here. If you feel free to maybe post on chat. But so far, whenever I ask this question, almost without, I'm very confident that a lot of the answers are going to be, it takes time to reproduce the issue. You don't always have enough information when the ticket is presented, which is a challenge, and you need to find the root cause and come up with a fix. But the biggest and most common problem in solving a customer's issue is being able to reproduce it. When we speak to customers moving to Kubernetes or expanding their microservices footprint, they speak about challenges, about identifying issues, setting the right alerts, catching all the exceptions on time, and aggregating them, building a reliable system for ticket handling and notification. This is usually something that they say they think is solved. The bug report or the support ticket not having enough information, I think, is what every engineer felt about every single support ticket that was transmitted to him. I can count on the fingers of one hand the number of support engineers that I knew that if they supported a ticket, it would have all of the log information, it would have all of the steps to reproduce the issue, it would have all the information about the configuration and the environment and the version, that they tried all the hot fixes and the workarounds, and that if they reported it, there is a problem and I need to fix it. And really, I can maybe name 1 or 2 support engineers and QA engineers where if they submitted an issue, they told me exactly what I need to do to reproduce the issue. I even worked with one engineer who would basically submit a unit test for me, that when I ran it, it reproduces the issue, and when I solved the bug, I can run the unit test again to solve it. But really, that's really the rare unicorn of support tickets. In most cases, you need all the information up front, and you need the right environment, the right configuration, the right conditions in time and space, and we're going to dig into that in a minute. After you have all of that, you still need to find the root cause and to change the code. If you have a reliable way to reproduce, you can also validate that you fixed the issue indeed, and you can also validate that you do not cause a new bug as you released it. And you have to do all of that with business on your back, with pressure and frustration and managers calling. So we're trying to understand how we can improve that. So since we believe that reproducing the issue and getting the information up front are the biggest challenges, we're going to try and take a step deeper and understand why these are hard to handle and why these are time-consuming tasks. And if possible, try to understand why they are even harder to handle in the cloud native and Kubernetes worlds. So getting all the information up front, there is just too much information that you need. And making sure that you have all of the log lines and all of the configuration with the ticket is very rare. And when you do not have all of the information, what you end up doing is either hot fixing a change in the code that adds a long line. If you're a cloud native application, it's even easier because you can just deploy it and no one will notice, but it still takes time. You need to change the code, you need to review it, you need to wait for it to go through the CI/CD pipeline. You need the incident to happen again. And if you are lucky and you did your job right, the log line was set in the right location and it has all the variables that you needed to understand what was going on. In Kubernetes, things become even trickier because there is a lot of information that is not just in the code. There is the configuration, the versions of the code that keep changing. The clusters are very dynamic. The network conditions are very inconsistent. And one of the things we try to achieve when we go to a microservice architecture is we want to make microservices independent. I write my component, you write your component. I do not need to know how your component works, and as long as you provide the API. But when an incident is discovered in my microservice, the root cause could be in your microservice or in some other service down the line. If I'm lucky, you and I work in the same team and we can share the code and we can look at it together and understand what caused the incident. In very often, we are not so lucky. And you end up tracing the issue down the line. And debugging someone else's code is even harder. Debugging an open source or debugging a proprietary library for another microservice is a bigger challenge. And of course, that all depends on the fact that you have a tracing mechanism in place and that you know how to use it, which is not always the case. So these are just some of the challenges we have with getting all the information up front with a ticket. When it comes to reproducing the issue, you need all the information. And as I mentioned, you need extra information about the Kubernetes deployment in order to reproduce the issue. And if back in the old days, I would usually be able to run a debug mode of the application on my desktop and try to reproduce the issue by achieving the same conditions. In Kubernetes, this goes between completely impossible because it's a different operating system, because my desktop just cannot handle the number of pods and clusters that I need to handle when reproducing the issue. Definitely not the network conditions, which are going to be completely different. And even if my team has a very reliable and believable staging environment, it is still going to be a challenge to reproduce the issue and simulate a microservice environment that is close enough to the live environment so that I can find the root cause of the problem. So just to recap, we said that solving customers' issue is a time-consuming problem, that the biggest problem we usually encounter is getting all the information up front and reproducing the issue. And we drill down into why these are usually the challenge. The next part of the conversation we have with our customers is when we try to understand how they try to solve these problems today. And this varies widely based on the maturity of the customer and the size of the organization. And sometimes it changes based on the type of the problem. If it's a very basic problem and you can reproduce it locally, then you are lucky. You run the application in debug mode. You set a breakpoint, you step by step it, and you find the root cause. Most teams who move to Kubernetes almost from day one, they understand that debugging is no longer an option, and they move on to rely almost entirely on logging. You have to print everything because everything is asynchronous. You have to print everything because you cannot stop one pod while the other services move forward. And you have to print everything and make sure that you have tracing context so that you can understand cause and effect. And if you did your job right and you have log about everything, then most problems you will be able to overcome with logging. But then the challenge is going to be what happens when a new incident happens. You need to add a log line, you need to wait, you need to make sure that it's pipelined to the right location. And this is sometimes a challenge. On top of that, building a reliable logging system is just something that requires a lot of R&D and specifically DevOps effort. Teams invest a lot of time in building these applications and maintaining them. So if you don't have anything, it may be even weeks or months before you have that solution available to you. Again, in the old days, if you're not using Kubernetes, you would just SSH and do some classic remote debugging in a machine. In Kubernetes, there is no machine for you to log into. There is no host name. And even if there was, DevOps and security would be very unhappy to find out that you are debugging directly into a live application, which is why most teams develop their logging further and install APM tools and try to build an observability platform. So if you are in the slice of the market that already has a very mature observability platform, you are lucky. Even those customers say to us, you know what, most of the issues I can reproduce quite quickly. If I had the right tools, I would be able to solve the other ones even faster. There are some alternatives that are specific to Kubernetes. Some solutions let you run a specific pod on your desktop while it communicates with other solutions running in the live environment. Other solutions actually let you debug remotely, just as you would expect in a local application. And at Rookout, we went with another approach. We wanted to find a way to troubleshoot an application in Kubernetes environment, in serverless environment, that would be as easy and straightforward as it would be when debugging locally. We want to look at the code. We want to set a breakpoint. We want to get all of the data instantly, just as if we were debugging locally. We call this technology non-breaking breakpoints. Some tools in the domain call it log points or trace points or snap points from the word snapshot. We went with non-breaking breakpoints because we wanted to say this is a debugger and a debugger has breakpoints. But we are a live debugger. We are not stopping your code. So let's quickly take a look and see this in action. This is Rookout. This is my web IDE in a sense, because it shows me the code and it lets me set a breakpoint. And the application that we are debugging right now is a very simple task management application. We call it the to-do app. It tells me what I need to do. And one of the things I had to do today was prepare for this demo. It's a very simple app. It runs in Java in a Kubernetes, in a single Kubernetes cluster in Google Cloud Platform. And one of the issues that I was just told that it has is that if there are some tasks that are marked as completed, and I click the clear completed button, these tasks do not get deleted. So I want to troubleshoot it and get to the root cause, but again, this is a live environment. So I want to be able to reproduce it with all of the network and configuration conditions. And I want to do it without stopping the app. So I'm going to visit my IDE again. And first of all, I'm going to make sure that I'm looking at the right environment. One challenge in debugging live applications is that you could be looking at production or staging. You could be looking at different repositories and different versions of each repository and each commit. So we want to make sure that you're looking at the live application. We handle that automatically for you. You want to make sure that you're looking at the right cluster and pod. You can use some labels and tags to let us know which pods you want us to look at. In this case, we're going to look at the Java tutorial application. And as I click Let's Go behind the scenes, Rookout is already deployed as agents within my Kubernetes pods, and it's going to let me fetch data live from these pods. So I'm going to take a look at the controller class, and I'm going to look for the function that handles clearing completed tasks. So I'm going to set a breakpoint. I usually just set breakpoints all over just to understand, to make sure that I entered the function, that I exited the function, and if there is a suspicious loop inside it, I'm going to try and catch a snippet of it. And when I trigger the bug again, first of all, you will notice that the application did not stop. Other users can add their tasks, and they can interact with the application. So I'm not interrupting the flow of the application. But what does happen when I click clear completed is that the breakpoint is triggered, and I instantly have a snapshot from the entry to the function. I also have a snapshot from the exit point, and I'm not getting a snapshot here in the middle of the condition. So I know that this condition was not hit, which is already a good hint towards solving the bug. And I also have all of the variables, all of the local variables in each step here, just as I would have when debugging locally. I have information about the process, and if it's a Kubernetes application, you want to know which pod you are looking at. You want to know the labels in the environment. You want to maybe get a hint about the CPU and memory of this specific server. I have the stack trace. And one thing that we actually are able to do is to let you set a breakpoint up the stack trace, even if you do not have the source code. So if I am debugging and tracing a problem down to a colleague's microservice or even a third party that I'm relying on, Rookout is still able to set a breakpoint on a third party and collect data for you, letting you know what were the values in the variables in that third party. So when it comes to troubleshooting microservices, this is a huge help. One last thing that we added quite recently is if you're using a tracing tool, we are also able to fetch tracing data. I do not have trace for that function, but I do have it for this one. So if you have any span, any context information that will help you track the info and make sure that you're looking at the right transaction or at a transaction that came from the right account, or anything that helps you find the needle in the haystack of tracing the root cause of the problem, we are also able to fetch that for you dynamically. A few other things I can do since we are using a live debugger, we can see a timeline view of the message if I'm trying to troubleshoot a sneaky bug and understand when it was last triggered, when this condition was last met, or try to understand how many times does a specific service get invoked in a specific time. We are also able to show this data. I'm able to set a condition to make sure that this breakpoint is only hit when these conditions that I want to identify are happening. So just like a conditional breakpoint that you would expect to set in your environment, you can set it here with all the expected logical conditions and make sure that you do not get too many snapshots and you get only the data that you need. And one thing that I'm actually going to show you, but I'm also going to cross my fingers because it's still kind of in beta, is we are working on adding some very basic profiling capabilities. Profiling and tracing are critical in the world of microservices, but they are also things that usually you think twice about invoking them because they may impact performance. But if you're able to activate them dynamically and on a very specific section of the code, you may be able to do that without hesitation. So cross fingers because it's a feature in beta, and let's hope that it works. I'm going to enter profiling mode, and I'm going to set two profiling methods in this function to try and understand how efficient this loop is going. And when I reproduce the issue again a few more times, I hope to see some live measurements of how long this function took to execute or this service took to respond. So I can try and understand if there is a bottleneck here and how consistent the timing is. One last thing that I'm going to show you, and I'm going to leave some time for questions, is we also have what we call the debugging heatmap or the debugging dashboard, where we try to show a team who in the team is using the tool, who in the team is brave enough to debug in production, or who in the team on the flip side is the poor developer who unfortunately has to solve everyone else's problems. What it actually gave us is the ability to see what areas in the application or what environments actually require the most live debugging. So if you see that most of the debugging here happens in production, or if you see that this specific service or that specific service is the one requiring the most attention, it will actually give you a hint about the quality of the application, not in the sense of how many alerts it's getting, but in the sense of how much time actually developers spend on troubleshooting this area. And another bit of information that, again, based on customer feedback, is we try to estimate how much time we can save you. So our customers, and I will show you a couple of quotes in a minute, because this is, after all, a sponsored session. Some of our customers tell us that Rookout lets them solve customer issues or reduce the debugging time by up to 80%. So we made a quick calculation, and we estimate that 10 minutes of using Rookout saves you an hour of debugging. So we take the time you spent in Rookout and we try to estimate the effort that we save you and the time we free up for developing new features or just having coffee with your team on Zoom. And with that, I will show you 2 more slides, and then we're going to break for questions. So just to recap, we've seen that the biggest challenges we had was not being able to reproduce these conditions. And by debugging in the live environment, in the actual environment, we do not need to spend time on duplicating the environment. We do not need to spend time on getting more information about the incident. We are able to reproduce the issue in its actual environment, which makes getting to the root cause of it much easier and much more efficient. We have some quotes from customers who use Rookout to debug their cloud-native applications in production, and they tell us that it helps them solve problems much faster. So I hope this will convince you as well. And if this was interesting to you, if you are interested in solving debugging Kubernetes faster and more efficiently, we invite you to reach out to us. And if you do not win the T-shirt at the end of this session, and we also invite you to reach out, and maybe we can arrange something as well.
Cool. Thank you very much, Oded. I think everyone will reach out to you to get a shirt. Yeah. Well, the presentation was super cool. We do got a question from Eric. What programming languages are supported?
Oh, yeah, I usually open with that. I'm sorry. We support Java, .NET, or, well, I say Java, it's JVM. It's basically Java in a lot of its flavors and Java-based platforms. We support .NET, both core and framework. We support Python and Node.js in the backend, not JavaScript front end yet. We just recently added support for Ruby a few weeks ago. And currently we are working on Go because that's the natural language to support when you develop a Kubernetes app. And we are looking for design partners. So if any of you are having challenges with Go, we would love to hear what are you struggling with.
Alex asked, what is necessary to onboard Rookout? And what is the performance impact on the application at runtime?
Yeah, so Rookout is installed as an agent. It's It's a NuGet package in .NET. It's a Java agent in Java. It's a single, usually a single command line to download the agent, and a single line of code to import the agent into your application. It varies from language to language, but it's always one package and one line of code, just importing our agent and running it side by side with your application. As for performance impact, we measure our application very strictly, and our customers usually run us through a test before they deploy us, even in staging, not to mention production. We usually see up to 1% impact on CPU and memory. And we have a lot of security, not security measures, but a lot of safety measures, making sure that a breakpoint doesn't hit too often. We have things like rate limiting, and most importantly, strict limits on how much data we're going to collect, how many variables, how many collections, how many arrays and string buffers, to make sure that we are not impacting your application in any meaningful way.
Edward Aigna asked if you support .NET fully, and if you can talk briefly how the support looks like. Also, what's necessary from an infrastructure perspective to work with Rookout. And I would like us to add to that question also, how is the licensing working? Is it paid? Is it free? Can I try for free? How it works?
Yeah, let me start with the easy and happy part. Rookout is available for free for a single developer with a small number of servers. So if you're going to debug your test environment, your weekend project, Rookout does have a free offering. Many of our customers are big enterprises. So we do charge money for large teams with hundreds and thousands of servers, but we also have a free offering. As for .NET, we can, I'm just sharing my screen here so you can see the languages that we support and the versions of each framework that we support. Usually, if the framework or the version that you're using is not here, adding another language is sometimes very easy for us in this family. So sometimes it's just as easy as identifying the file name and making sure that there are no big surprises. Sometimes when adding a new version, we need to change some of our internal APIs, but we try to cover what the market is demanding us and what the customers are telling us.
Cool. Edward, does that answer your question? I'm not sure what you mean by fully support of .NET. If you want, you can unmute yourself.
Yeah. I wanted just to know if there are some restrictions or drawbacks in using .NET 5, and yeah, that was mainly the question, and also how the developing looks like with Rookout if I'm using the .NET environment. Let's say how it looks like when I'm using Visual Studio and the like. So maybe you can also elaborate a bit on that. It'd be interesting.
Sure thing. So as for the first question, I cannot think of a specific limitation we had or a customer issue we had specifically with .NET 5 or indeed with other .NET versions. Sometimes we find like some edge cases like some flakes of the language that in order to support local functions, we need to do something else. In order to support async functions, we need to do something else. But it's usually something that we handle quite quickly. So I wouldn't say there are significant limitations that we are aware of. As for developing it side by side with Visual Studio, I will say that what I showed you looks and feels like a web IDE. It's not really an IDE. It's a web debugger. So at the moment, we do not integrate with Visual Studio or with other IDEs for the Java languages, but it is something we may add in the future. So at the moment, we expect development to be where you write the code in Visual Studio, you push it and you deploy it. And when there is an issue and you need additional data, you can fetch it from Rookout. One important point that I did not mention is that we have the ability to send data to relevant observability platforms and logging tools. So we are able to integrate into your development cycle. Some customers use this as a way to basically get alerts and get log lines sent to Slack. Some customers send this data to their APM or their profiling or their alert triggering mechanisms. And some customers basically just use our integrations with some collaboration tools just by sending a link to the web application. So I hope that answered your question.
Yeah, that answered it. And also comes the next question: what is necessary from an infrastructure perspective to work with Rookout? As I said, it's a web interface mostly. I can set the breakpoints.
Yeah.
But also for the infrastructure, would they need special storage? What are the requirements, or also for access on the machine cluster, etc.?
Yeah. So for the web interface, we just need a browser. Most of our customers use Chrome, usually running with latest and greatest. Things work smooth. As for the deployment itself, since we run in the application itself, we have no hardware restrictions on where the agents run. So as long as your application can import our NuGet package, we can run inside the application.
Mm-hmm. But it's mostly I have to install the NuGet package for the agent, and I installed the web UI server, and more or less that should do the trick, right?
Yep. Most of our customers are able to deploy this on their own. We do see an experience that in advanced environments, usually when it comes to platform as a service deployments and definitely serverless deployments, we are happy to jump. One of our engineers is happy to jump on a call and make sure that the installation runs smoothly. But really, it's just a matter of importing the NuGet package.
Okay, thank you.
We have I think a quick question from Dimi. Do you support on-prem deployment?
So we do not have a full on-prem deployment. That is the Rookout web application is only provided as SaaS. We do offer what we call a hybrid deployment, where the agent is running on-prem, and we provide a data controller that can be running on-prem. So when that is used, your application is running on-prem, all of the data is staying on-prem. Your code, I did not mention this earlier, your code is always on-prem. Your code never reaches the Rookout server. It is loaded into your browser, but it never leaves your network. It always stays between your browser and your source control management. The only thing that gets transmitted to Rookout is just the file names and the locations where a breakpoint is set, so that we can invoke and control the agents as they basically apply the breakpoint. So we do not have a full on-prem option. We do have a hybrid option that keeps all of the data, all of the sensitive customer data on your premises.
And I'll say the last question here from Christian. Especially in Java, he assumes that you are doing bytecode instrumentation. Are you working well alongside with other agents that are doing the same? For instance, Dynatrace?
Yes, I'm smiling because we get asked about this a lot. We are able to run with other agents. We haven't tested with Dynatrace recently, and I will not mention other agents that we have.
The meetup is not something
Yeah.
that is bound to the company, so
yeah,
no problem.
I will say that we have recently partnered with AppDynamics and with Cisco, so we have thoroughly tested the ability to run side by side with their agent. We have customers using Datadog, and we run side by side with their agent. With Dynatrace shouldn't be an issue as well.
Thanks. Jürgen, anything from your end?
Thanks Oded for the great presentation. Thanks everyone for all the questions. That's really great to get all these questions. And I tried already a little bit in the background to prepare for our next part here in our meetup. Let me just introduce what we have planned. So we know that a meetup is all about get to know each other, to learn about exciting technology, but it should also be fun. And it's can you see my screen? It's working, right? Okay. So what we've already also discovered at other meetups where we are presenting or just participating is we want to kind of make the next 15 minutes fun for you. And we have come up with the idea of doing in Zoom, do a couple of breakout rooms. We will create breakout rooms and we will assign you randomly to these breakout rooms. And the idea is that you discuss one question that is assigned to your room. So you only have one question, basically, that you can discuss in your room. It will be 4 to 5 people in the room. We will actually stop recording. So I will stop recording right now.